Hello everyone, we are Team LOGICTRONS from Techno India Salt Lake, Kolkata. I am Suvadip Samanta and here is my team.
Hi, I am Moinak Ghosh.
Hi, I am Subarno Banerjee.
Hi, I am Sujay Basak.
We present our project in the field of smart and digital asset ecosystem named as Smart Waste Management System.
Our aim is to provide a clean and tidy society through an IOT based waste disposal procedure. Our solution is technically feasible and can be implemented practically through a closed loop system.
As the conventional methods of waste disposal leads to a toxic environment and an unhygienic society where the dustbins release foul odor, our emphasis is to search for new and innovative solutions. Unhandled waste and irresponsible dumpings attracts many germs, which is the root cause of many diseases.
So, our system proposes a smart dustbin equipped with different kind of sensors which sends real data to the server for analysis. By the analysis, we have made a data set for which is used for further different processing for the use of our system. Here we have made some user interface for the use of the general user and different peoples. This system is better than the general conventional system which is used, and I think this system will make a better future of us.
Now let us proceed with the detailed description of our proposed solution.
In India, one of the most prevalent problems are the management of waste on a daily basis. As we can see, on every corner of the road, there are overloaded waste bins and excess flowing waste on the road. This leads to a number of problems throughout the city. These problems include clogging of drains, liberation of foul smell, and also degrading the scenic beauty of the country. Another problem faced by the local governing bodies is timely and uniform disposal of waste generated on a daily basis. To overcome these problems, what we propose is a smart waste management system. In this system, every dustbin will be installed with proper microcontrollers such as Arduino Mega, Wi-Fi modules such as Node MCU ESP826612E, and relevant sensors such as ultrasonic, temperature and humidity, toxic gas sensor, and also weight/load sensor. The value generated from these sensors will be fed to a dedicated cloud server via the ESP8266 Wi-Fi module. The data collected at the cloud server will be organized according to the date and time. The collected value in the cloud server will be used for implementing machine learning techniques, and also it will be used for proper collection of waste by the local governing bodies. These values will be fed to an independent IoT platform cloud so that regular real-time monitoring of the bins is done from a central server, and each and every garbage collection truck is able to collect maximum amount of waste in minimum amount of time with the help of KNN and regression. The values collected in the cloud server can be viewed via an app from the user perspective and analyzed and regularly updated from the web server from the administration point of view. The advantages of these installed dustbins is innumerable. Firstly, there will be timely and proper disposal of waste every day on a regular basis. Another advantage will be that there will be no overflowing of garbage, as whenever the bin is filled to a certain critical amount, the garbage collection truck nearest to that point will be notified for collecting that waste. The problems such as clogging of drains or littering of waste will be eliminated to a huge extent. Last but not the least, the scenic beauty of the entire city will be restored. We also have planned to incorporate one more feature in this venture. That is, whenever someone from an user point of view is dumping waste in proper waste bins, they have the privilege to scan a QR code installed on that smart bin, which will enable them to gain points. Another aspect of this proposed solution is the main cost is during the installment of the product. Further processing and further maintenance cost is very low, and the collection of waste in proper time on a daily basis will be completely under the control of local governing body.
Here we have made the mathematical model of our proposed solution. Here the total model and the flow by which for the each input the each output has come, that is shown. Now at first we have demonstrated the volume part. We use ultrasonic sensor for the volume part. Here we have seen that first a random value is taken, which a constant is multiplied with it, and then that is come to a product block, and another constant is added with it, then it is come to a summer, and another user input which is D is added with it, and then it is come to a percentage block, it is divided, and by it is come to the output. So you can see that a percentage volume, it is extracted from the input of the distance of the ultrasonic graph. Now if you simulate it, we can see the random output of the volume here. For each input of the distance, a percentage is generated and each output is demonstrated. Now if we see the MATLAB code of it, if we generate a random function of the volume part, if we give a random input of the distance, let us give it here, that we can see the transfer function also. If we give the random input of the distance, we can see a random output of the percentage in the output command window. So by the transfer function we can see the VD minus R by D into 100. We can generate the percentage of the height or the volume by the transfer function. Now let us come to the moisture. It is a more or less same mathematical model. We are generating the percentage of the moisture. Here we are giving a random input that is multiplied by the constant, and that is come to the adder, by the adder block come to the final adder. Then a uniform random number, which is the input of the user, it is coming from that, and at last the percentage, after the percentage block, that is come to the output. Now here we can also see that for each user input, another simulated data is generated. For the percentage or the value of the moisture, the total percentage of moisture is seen. Now if we come to the MATLAB code, we can see the transfer function V equal to M minus R by M into 100. By the transfer function we can generate the simulated output of the random moisture percentage. Now you can see, if you see the command window here, if we run the code, if we run the function here, then we can see that the output of the moisture percentage, it is demonstrated here. Now let us come to the next code, which is the Dijkstra's algorithm. Now if we consider Dijkstra's algorithm, it is the shortest path algorithm in a graph. The graph consists of nodes, and in this project we are considering the Dijkstra's algorithm is demonstrated on the map on which the bins are allocated. Now we can see we are considering that the bins position locations are the nodes here, and the central part, which is the admin office, that is the preliminary node, and the total weightage, the distance from each node, that is the weightage of the links. Now if we see the code, we are making a function, there is a distance and path, and making a disaster algorithm where we are input the respected inputs and we are segmenting the maximum segmented length, and here we have generated a formula for which the output of the disaster algorithm is made, that is number nodes into number nodes minus 1 by 2. From here we are generating the output of the disaster algorithm, which is generally we can do by our hand also in a disaster algorithm manner. Now if we run the code here, we can see that the simulated graph is generated. Now suppose we are in the graph, we can say that from node 9 to 34, there are two bins, and we can see the minimum path that the driver or the garbage collector can follow to collect the bin. So it is a perfect algorithm to traverse the map, and the driver can easily go to is following in this research location in the minimum path by this algorithm. Now after this, we can directly move to our new concept. If we have the latitude and longitude of two destinations, we can get the distance of the minimum distance of the curvature part. Now if we see the code, there is a transfer function. We have considered three variables, and by simulating these three variables, we can see that if we run this code, the output d is the distance is respective of the in the dimension of kilometers, the distance from a node to another node if we get the node latitude and longitude. Here we can see that a, c and d are the variables. 6371 is the radius of the earth. Now if we run this code here, we can see, if we run the function here, if we are giving the input of the latitude and longitude here, we can see that 50.6066 and more and less. Here we can see that this is the latitude, longitude, and this is the distance of the latitude and longitude point. So here we can say that this distance is the minimum distance, the distance of the path. So the garbage collector can know that this is the path he has to traverse, but this is not the way he has to traverse. This is the distance of the path he has to traverse. The path is always located by the disaster algorithm. So these are the mathematical models which is generally made on our proposed system, and by simulating this mathematical model, we can simulate our system and we will get our desired output.
Now let us discuss the flowchart which is initially created for the app. This is the monitoring flowchart for the users. At first, the users approaches the bin. He reads the bin status in the app. If the bin status is greater than 40%, and if he dumps garbage into it, then it's the color of the RGB LED in the bin changes to yellow, and the same data is reflected onto the app. If he doesn't dump waste, then the status of the bin is retained. Next, if the status of the bin has a load of greater than or equal to 70%, then the color of the RGB LED is yellow. Now, if the user dumps waste into it, the color of the LED changes to red, and the same data is reflected onto the app. If he doesn't dump waste, then the status of the bin is retained to yellow. After this, the flowchart ends and the cycle ends here. Now, the flowchart of the waste collector. At first, the waste collector starts his trip with his garbage truck from the headquarters, which is the primary node. He observes and receives the data, that is the status of the bins. He is also defined with the route through which he should collect the bins. He should approach the bin with higher amount of fill at first and the one with the lower amount of fill after that. Now the optimal path is generated through which he should collect the garbage from the bins and return to his headquarters with the garbage, from where he will again go to the dump yard where he will dump the garbage. After the collector clears each bin, the status of the bin is refreshed and all the bins are which were previously filled are now set to 0. Now let us discuss the digital model of the working of the RGB LED fitted into the waste bin. At first, the AC current is delivered to the AC to DC converter through a switch which is fed to the Arduino microcontroller which is fitted with an ultrasonic sensor. Now here is the formula through which the RGB LED is calibrated to work such that it displays the colors of green, yellow and red according to the fill of the bin. The ultrasonic sensor senses the height of the garbage inside the bin and accordingly it is programmed such that the RGB LED shows the color of the fill inside the bin. Now let us discuss the working of the servo motor which helps in the locking and unlocking mechanism of the bins which will be controlled by the collectors while collecting the garbage. Here is the mathematical equation on how the servo works, and this can be termed as a digital model which serves as the digital twin of the system. At first, the AC current passes through the switch which is then fed to the microcontroller which is connected to the servo. A servo has 3 pins, namely VCC, ground and the third one which works on the pulse width modulation. If the pulse fed to the servo is of width 1 millimeter 1 microsecond, then the shaft of the motor is in lock position. Now if it is programmed in such a way that if a neutral pulse of pulse width 1.5 microsecond is passed through the servo, then the shaft of the servo motor rotates to 90 degree and the lock opens such that the garbage collector is able to open the bin in order to clear the garbage inside it. This locking and unlocking of the servo motor is calibrated through this and controlled through the microcontroller through a code embedded inside it and is controlled via the app interface of the collector.
Here we have written a code which is run on a microcontroller ESP8266 node MCU. From the node MCU, the value has transferred to a dedicated server and a IoT based cloud platform. Now we can see that here we have generated 5 random variables due to lack of real data. We have generated this simulated data which is volume, toxicity, moisture, weight and temperature. Now we have sent this data to the server. This is a link from which the data is going to the server. Now it is the total code by which the data is going to the HTTP server and the data is stored in the server. Now if we run the code here, we can see that if the Wi-Fi is connected, then in the serial monitor we can see that the variables and the tokens, and for these respective tokens the value is generated, and if we can see the server, the value is stored in the server also. From the cloud server we have extracted a CSV file. In the CSV file we have all the records. For 3 dustbin we have these respective records: moisture, temperature, toxicity, volume and weight. In this CSV file we have simulated the data for a machine learning algorithm. For that we have used Anaconda Navigator, Jupyter Lab. If we launch the Jupyter Lab, in this we have written a Python code where for analysis we can have a proper machine learning algorithm, and proper outcome of it will guide the garbage collector which path should be taken and which garbage bin should be collected first. We have to import some files here. After importing the files, we have imported the CSV file in the bin data, and after running it, we can see the data of the CSV files here. Now the data is described in such a criteria of standard deviation, mean and some percentage of values. If we see the columns for different bins, the data variation indicates the percentage of the quantity of the data. Now if we plot that as a pair plot, then for each 3 weights, the 3 volumes are plotted in a matrix manner. Now if we plot a line plot of volume versus weight, we can see that at first for the increasing of the weight, the volume is also increases. After the weight 1500 to 2000, the volume decreases rapidly. It concludes that at first there is plastic weight, and after that some solid or heavy material weight incorporates that, so the volume decreases and the bin is compressed. After the following graph, the random change of volume and the weight is shown in the graph. Now if we plot here the bin data, weight versus toxicity in a broader manner, that means if we enlarge the graph in the interval of 2800 to 3500, we will explain this for the change of the toxicity with respect to weight in detail. Now if we plot weight versus toxicity for each 3 bins, we can see a very interesting point that for bin 3, the toxicity level is constant for the range of 2900 to 3500 weight. So we can conclude that this bin is situated in generally household complex. In household complex, generally little less toxic weights are generally used. The bin toxicity is not increasing very much. If we consider the blue line, so we can see that in bin 1, for increase of weight, the toxicity increases rapidly. So we can say that this is for the waste of the industrial purpose. And for the orange line, we can see the toxicity decreasing. That is maybe the plastic weight. We have generated a function that is called peak yes no. Logic of the function is that the total criteria is mentioned on the priority of the each parameters. The main priority is toxicity, then is come to the weight and volume. So if the toxicity is greater than 9, we are returning 1. If the toxicity is less than 5 or greater than weight is greater than 4900, we are returning 1. And if the weight is greater than 4900, otherwise returning 0. And if all the case is false, we are returning 0. If the toxicity is higher and the weight is high, so all the value is 1. So we have to empty the bin immediately. So here we can say that total priority is depending on these 5 parameters. At first, the toxicity parameters take a major role. If we see that the toxicity is becoming very high, we have to immediately empty the bin. But if we see that the toxicity is not that much higher, but the volume is very high, but the weight is less, then we have to empty the bin. But if the weight is very high, that is further cannot be taken by the garbage collector, but the volume is not full, then that is also should be clear.
Here we are showing the HTML and PHP codes used while making the web page, which is solely meant for the administrators. Here is the HTML page for the main web page, and now this one is the PHP page for the different bins. For this time we have only taken 3 bins, bin 1, bin 2 and bin 3, but it can be later increased as per the requirements of the number of bins installed. Now let's go through another user interface, which is a web interface. This is created solely for the purpose of the administrators to take a note of the current status of all the bins. This is our web interface, which consists of the basic interface through which the administrators can take a note of all the bins as installed in the city and note their current statuses. By clicking on these buttons of the bins, the administrator can view the volume, moisture, weight, toxicity and temperature of the bins through a graphical representation. This graphical representation is solely real-time data and is fed every 30 seconds into the server. Now let's discuss the collector login interface of the app. When a collector opens the app and goes to the collector login, he will find a page which will ask for his login ID and password. He will sign in using a predefined login ID and password. After successful signing in into the app, the collector will be able to see a similar map interface and the markers of all the dustbins surrounding him. Now after reaching the bin, the collector will select the bin to see the real-time status of all the bins. If he finds the bins filled of volume or moisture or any of the critical values of all the aspects, he will then open the dustbin using the app and then clear the garbage, and then he will also be able to close the app similarly using that same switch. This locking mechanism is operated through a servo motor fitted inside the bin. The switch operates the opening and closing of the servo motor, which in turn processes the bin to lock and unlock accordingly. Now let's go through the app interface, which is the main user interface as proposed earlier. Our app interface consists of two panels, one is for the users and one is for the collectors. The user login is the interface from where the user logs into the system. If the user doesn't have a previous account in our system, he has a button through which he can sign up. If he clicks on the sign up button, he is then redirected to a page where he has to put in all his personal details like name, mobile number, email ID and his desired passwords, from where all his personal details are recorded to our database, from where it is fetched when he logs into the system. Now after successful signing up in our app, he can now use his email ID and password to log in to the system. After logging in, he will get into the map interface, where in the map he will be able to see all the bins. Repeat, after putting in his authenticated credentials, he can sign in to the app, from where he will be redirected to the map interface where he can see the markers where the dustbins are located in the locality surrounding him. If he clicks on each dustbin, he will be able to see the real-time status of each and every dustbin. Like the sensors fitted into the dustbin, the real-time data are fed to the server from which it is fetched and shown in the app. The sensors include volume, moisture, weight, toxicity and temperature. After that, he will dump the waste in the bin if the bin is free of space, and then he will scan the QR code, from which he will be able to obtain the feedback points which he can later redeem.
Talking about the business model of our proposed idea, the software analysis and road condition reports will provide the optimized route for better collection of waste following the shortest route and minimum time possible. With proper implementation, we need less trucks, less fuel, and most importantly, less time, which will ultimately reduce the operational and maintenance cost by 80%. The main advantages of our proposed idea is significant rise in waste collection rate, reduction in cost of waste collection, a steady decrease in the number of required waste collection trucks, fuel cost and CO2 emission is hugely reduced. Improved waste management through real-time system reporting will ultimately be able to fulfill the goal of a waste-free environment and a green city. With availability of funds, we would like to build a prototype consisting of 4 dustbins with all the installed sensors and required electronic devices. In each bin, the required sensors would be DHT11 temperature sensor, ultrasonic sensor, a GPS module, toxic gas sensor, load sensor, Arduino Mega, ESP8266 Node MCU, RGB LEDs, moisture sensor, battery for power, and a single dedicated IoT platform or cloud server. The expected cost for manufacturing the entire system of 4 bins is approximated to be 15 to 20,000 rupees.
So this was the brief description of our project, a smart solution to design to save money and to keep street clean. If we implement this system, the total scenario of garbage collection will be changed. This technology will be a significant step towards reaching the goal of 100% green city. Thanks for watching.